I'm VK Jalisha, Assistant Professor, Department of Mathematics, St. Joseph's College of Arts and Science for Women, Hosur. Today we are going to see how to construct truth tables and what is meant by equivalence formulas with some special connectives in proportional logic topic of discrete mathematics. So before moving into the truth table construction, we need to know what is meant by converse, contrapositive, and inverse. Converse means for P tends to Q, its converse is Q tends to P. Converse means the answers will be in the reverse order. So check the yellow and green columns here. In the yellow column, true, false, true, true. Its reverse order is given in Q tends to P. So we can say Q tends to P is the contrapositive of P tends to Q. Next is contrapositive. Contrapositive means inverse the whole inverse. So for example, 2 inverse the whole inverse will be equal to 2. So if we are saying a statement is a contrapositive of another, then both values will be same. So let's check here what is given in the definition. P tends to Q whose contrapositive is Q tends to negation Q tends to negation P. So here we got the value of negation Q tends to negation P, and that is combined with P tends to Q. Both are having the same answer. So we are saying those two are the contrapositive of each other. And the last one is inverse. Negation P tends to negation Q is the inverse of P tends to Q. This is also similar to that of converse. Negation P tends to negation Q answer will be in the reverse form of P tends to Q. So check that in the table. P tends to Q is true, false, true, true. Negation P tends to negation Q is in the reverse. From the bottom to the top, it is given here. So it is called as the inverse of P tends to Q. Let's move into the next topic. Let's move into the next slide. What are the contrapositive, the converse, and the inverse of the given conditional statement? The home team wins whenever it is raining. For this compound sentence, we are going to define the conditional statement P tends to Q as if it is raining, then the outcome, the home team wins. So here on representing P tends to Q, the first part represent the statement P and the second represent the statement Q. We know the contrapositive of this conditional statement is negation Q tends to negation P. So negation of P from the previous line, we can say it is not raining. What is negation of Q? The home team does not win. So framing those negation Q and negation P, we can give its conditional. If the home team does not win, then it is not raining. The contrapositive is always equivalent to the given original statement. Then we are going to frame the converse of P tends to Q. The converse is of the form Q tends to P. So Q means home team wins, P means it is raining. So we can say here if the home team wins, then it is raining. The inverse means it is represented by negation P tends to negation Q. What is negation P? It is not raining. Negation Q means the home team does not win. So using that, the biconditional is applied here. If it is not raining, then the home team does not win. These are the examples of how to give the sentential framing using the logical operators. Next is how to construct a truth table. So here given question is P cup Q negation Q tends to P cap Q. The bracket is must here. It defines the a single compound statement and how we are connecting those two to frame another compound statement. So that bracket representation is called as the parenthesis. Okay, we all know how to give the truth tables for PQ. and negation q. Negation q means opposite to that of q values. Here it is true means false, false means true. Likewise, we have constructed negation q value. Next, we need to find p cup negation q. Cup means, according to its definition, any one value of the given 2 is true means answer will be true. So, which values we need to consider is here p and negation q. At least one value of these two columns is true means answer will be true, otherwise false. The next one is p cap q. According to the definition of cap, both are true means true, otherwise it will be false. So here we need to consider p and q. P and Q. So both should be true. So here both are true means answer will be true. For all the remaining, both are not true. Hence the answer is given as false. Now the final answer we need to give is applying conditional statement between these two parentheses. So in the conditional, first sentence is this and the second sentence is P cap Q. So for conditional definition, for the first, we need to check what are the true values. In that, if the second one is false, answer will be false. So first one is true and the second one is also true. Second means conditional, second part is true. So the answer is true. But in the second line, conditional's first part is true, whereas the second part is false. So according to the definition, we are giving it as false. Similarly, for the next to true, the second part is false, so answer is false. The remaining one, we did no need to check anything because the first one is true. So directly we can give the answer as true. So this is how we need to construct the truth tables. Here is about equivalent proportions. When two compound proportions always have the same truth value, then we can call them it as equivalent to each other. So if they are having same truth values means applying cap will get all the values to be true. Then that type of answer is called as a tautology that I'll explain in the next slide. So now the compound proportions P and Q are called logically equivalent if biconditional Q is the tautology. That is, I've explained in earlier. The notation P similar to Q, the three lines similar to Q denotes that P and Q are logically equivalent. Now here I have given an example for equivalence logic. So the question given in this statement is negation of P cap Q and negation P cap negation Q are logically equivalent is the thing to prove. So for that, what are the things we need to have? What is the value of P, Q, then negation P, negation Q we need. So PQ is given. With that, first we get the value of P cup Q and its negation. So P cup Q, any one is true means true. We have framed this column. Its negation means opposite to these values is given in the next column. Next value we need to find is negation P cap negation Q. So for that we are finding negation P opposite to that of P. Negation Q is opposite to that of Q. Those two columns are noted here. With these two columns we are finding its cap value. If both the values are true means answer will be true, otherwise false, which is the definition for caps. So using these two statements, that is negation of P cap Q and negation P cap negation Q, we need to show whether they are logically equivalent or not. So we are applying the biconditional. What is the biconditional statement definition? Both the values of the given statements are same, it gives the answer as true. So check here, which I have rounded here. In that, the first statement is false, the second is also false, same, so true. Next is same, true, again same, true. The last is same, true value, so answer will also be true. So all the values of biconditional of the two given statements are true means it is a tautology. Hence we can say those two statements as a logical equivalence statement. Already I've explained tautology means the output of the given parenthesis should be true. Then it is called as a tautology. If suppose all the values of our output is false, means we can say it as a contradiction. If a statement's output is neither a tautology nor a contradiction, means it is called as a contingency. So here I have given an example for contradiction. P and negation P whose cup value is noted and its negation value is noted. So cup value is fully true and cap value is fully false, which is a contradiction. The third column represents the tautological phase. So here are some practice questions. Please go through with that. And next topic we can go through with the topic equivalence by sequential application of implication and equivalence formulas. Thank you all.